Okay, solving a trigonometric equation. In this case, we have tangent of theta minus pi over 2, all on the inside of this tangent is equal to 1. And our goal is to find all the values of theta, this angle, between 0 and 2 pi that are going to give correct solutions. So as I get going on this, what I like to think is there's more stuff on the inside of this tangent than we normally see on some of these problems. So if we kind of simplify this down, if we think about this as if that was just some plain old angle x on the inside of our tangent and it was supposed to equal 1, just like our tangent of this more complicated on the inside equals 1, then we would be able to solve this one pretty easily in thinking, well, if I plug in a pi over 4 in for our x here, it's going to produce a positive 1 as an output. And typically what we do is to show all of our solutions, if it wasn't restricted between 0 and 2 pi at the end here, what we would do is add to it the period of tangent, which is just pi, multiplied by k, where k is some integer. So like 0, 1, 2, 3, or negative values could also be plugged in here as well. So that's the thought process going on here. Ours is more complicated than just plain old x being plugged into tangent. Instead, ours is going to be this theta minus pi over 2 is going to occupy the exact same spot as where x is in our solution. So I can say theta minus pi over 2 is going to equal, well, pi over 4 plus pi times k. And we haven't solved this down for theta yet, but all we need to do from here on out is first solve this down for theta. So move the pi over 2 to the other side. So I'm going to add that to move it to the other side. So it's going to be a positive pi over 2 over on the right-hand side now, plus pi over 4 plus pi times k. Probably go ahead and combine these together. So I'm going to visualize this as a common denominator of 4. So I'm going to think 2 pi over 4 is equivalent to 1/2. 1 over 2 is equivalent to 2 over 4, plus pi over 4, plus pi times k. So that's really 3 pi over 4, plus pi times k. Now this would be a way to represent all of our solutions. However, we're wanting to find specific solutions on this kind of restricted range between 0 and 2 pi. So what we're going to do to find those are we're going to fill in different values for k. So the easiest one is going to be if we plug in k equals 0. Then our theta is going to be given by 3 pi over 4 plus pi times 0, which anything times 0 is going to be 0. So 3 pi over 4 plus 0 is just 3 pi over 4. That definitely fits in between 0 and 2 pi. Let's move on to k equals 1. All right, so if k equals 1, we get 3 pi over 4 plus pi times 1, which will be 3 pi over 4 plus 4 pi over 4 with a common denominator. 4 over 4 is equivalent to this 1, which will give us 7 pi over 4. 7 divided by 4 is still smaller than 2. All right, it's like 1 3/4, which is smaller than 2. We could try additional values for k, but these are going to get too big. So we get theta equals 3 pi over 4 plus pi times 2, or 2 pi. But if we have 2 pi plus some positive value, that's going to be bigger than our 2 pi that we're looking for. So that's not going to produce a solution. You could also try negative values of k if you wanted to. Say k equals -1, but that's going to give you 3 pi over 4 plus pi times a -1, which is going to be -1 pi plus 3/4 of a pi is going to give you a negative result overall. So it's going to be smaller than 0, and it's not going to fit in these bounds that we were given. So we're going to get rid of that solution and say our only two solutions on this one are going to be the 3 pi over 4 and the 7 pi over 4, and that would be what we'd use for our theta. So I hope this helps out as you're working on solving trigonometric equations. Good luck.